Thanks for joining us for Phosphorus Science Now. I'm Matt Schultz with the Sustainable Phosphorus Alliance. You might not want to think about it, but every time you flush the toilet in the US, you're ultimately sending phosphorus to a wastewater treatment plant. From there, it's almost always either discharged to a water body or captured in solid residuals from the wastewater treatment process, and those residuals are called biosolids. How much of our agricultural demand for phosphorus could theoretically be displaced by the phosphorus we flush? And what prevents us from doing so? To discuss these questions, I had the pleasure of speaking to Minhazul Islam, who was just about to defend his doctoral dissertation at Arizona State University. He worked with collaborators to assess the potential for recycling wastewater phosphorus for agricultural use and the barriers to doing so. Their work is published in the journal Science of the Total Environment. Okay, Minaz, thank you so much for joining us for Phosphorus Science Now. I'm looking forward to hearing about your paper. Can you tell us a bit about it?
Hi, thank you so much for giving me the opportunity to present our work on the closing the phosphorus loop spatial analysis of potential for wastewater-derived fertilizers to meet US agricultural demand. So in this paper, we looked into the existing databases on wastewater phosphorus information and how the biosolids are being applied in all over US in the current state. So at the very beginning, I want to just give you a very bit of information about my co-authors and also the funding sources. So I have compiled this paper with multiple universities collaborations, like with University of Kansas and University of Arkansas. From University of Kansas, Argajit Shaha collaborated with us on this project, and Becca Munich. She was preliminary in at Arizona State University, but then she moved to University of Arkansas. But we actually started that work for a very long time. And giving from all this work actually is funded by STEPS, which is a NSF science funded research center, and all of this work very initially was the idea to build a comprehensive database on the phosphorus sources from wastewater.
Great, thanks.
So
Yeah, feel free to jump into the paper, Minaz. Thanks.
Okay, giving you a very big background at the very beginning, so we know from the existing databases that there are around 17,000 municipal waste treatment plants in the US, and these treatment plants are actually a massive phosphorus input-output sources, and we all know that USA applies around 2 million metric tons of mined P annually for agricultural purposes. So in the STEP Center, we have a goal to meet 25% of the mined P demand through alternative sources like wastewater phosphorus and other means of phosphorus recovery. And we also have noted that in the wastewater phosphorus, there is like more than 25% of phosphorus that actually exists in the sewage flush that is recoverable. So, through the existing recovery processes, like we can actually recover up to 90% of the phosphorus that is exist in the sewage sludge phosphorus. So, from this background, we came up with a research question that how can existing data sets be used to identify the contribution of municipal wastewater treatment plants in the United States to phosphorus recovery, and how can we assess the effectiveness of this recovered phosphorus to meet the geospatial demand of the agricultural fertilizers from recovered phosphorus. Um, to achieve this overall objective in our research, we developed a workflow based on the CWNS 2022 database, and we already had a database from a defective reuse modeling work that had existing database from the earlier CWNSS records. And from there, we identified the treatment plants locations and their design capacity and quantified how much raw waste phosphorus concentration we can have through these treatment plants. And from these 17,000 treatment plants we are talking about, we selected the largest 200 treatment plants based on the raw sewage phosphorus flow in these systems. And from there, we tried to answer the question that how much phosphorus flow actually occurs in the treatment plants and how mined P fertilizer demand can be offset by this raw sewage phosphorus flows. And not only that, we focused on actually the end product of the municipal sewage, that is sewage sludge. And we compiled data from NEBRA biosoil data projects and also used information from the US EPA Biosolids annual report and pulled information about sludge, sewage sludge concentration of phosphorus from US EPA TNSS databases. And from the NUGIS commercial phosphate database, we know that how much mined P demand exists in the US. From there, we calculated like total amount of dry metric tons of sewage sludge phosphorus, and also we categorized this sewage sludge flow, like how much is going to be land applied, how much is being land filled, and other means we are using. And from there, we developed a total sewage sludge disposal classification where we quantified from these 200 largest treatment plants how much sewage sludge is being land applied or landfilled or incinerated or used in other means in the US. Um, from the results, we actually first we mapped for all the treatment plants on the left hand side figure. You were seeing all the treatment locations in different color coding. The different color coding is showing you their design capacity and also how much phosphorus flows we're having in different concentrations in these treatment plants. And also we can see the large corn band areas like that where actually we have a lot of phosphorus demand in the agricultural sector in the US. And with the yellow star colors, you are seeing the urban centers, like actually where we have the most of the largest treatment plants and where actually the large wastewater treatment plant phosphorus hotspots exist.
So Minaz,
Um,
can I interrupt you for a second? And just in this figure, MGD is million gallons a day of influent to each of these plants, right?
yes,
Okay, and then tons per year, that's the amount of phosphorus in that influent.
yes.
Yeah, great, thank you.
Yeah, so on the right-hand side, we developed a cumulative distribution plot from the treatment plants from largest to smallest chronological scale, and we did that to identify like, okay, how much phosphorus is actually we can achieve from the largest treatment plants that accounts for the 50% of total total phosphorus in the wastewater sectors in the US. So you can see on the right-hand side plot that up to 200 treatment plants that actually accounts for around 50% total P, that is around 1.1 million metric ton, and the 50% is around zero point 0.3 million metric ton per year. So on the basis of that, actually we selected this largest 200 treatment plants to look at what is the existing the sewage sludge disposal practices in the US. And in the different color coding, you are also seeing like the range of phosphorus concentration that we accounted for in our analysis. So on the basis of the phosphorus raw sewage, we also wanted to know like how much phosphorus of this in this raw sewage is actually can contribute to offset the demand of mined P phosphorus. So to develop that, we developed a phosphorus use ratio metric at county scale. So in the first one, we analyze, okay, if we account for only individual counties, in the individual counties, how much raw sewage phosphorus from wastewater can be used to meet the P fertilizer demand at those counties. And in a second analysis, we accounted for the neighboring counties. Like, okay, if the individual counties are able to meet or not to meet, then if they are also supplying their raw waste phosphorus fertilizer in the neighboring counties, how that can actually alter this P phosphorus use ratio metric in all over US. So to develop that, we did this analysis in two types, like one is individual county phosphorus use ratio and the other is neighboring county phosphorus use ratio. And to show you the results, I want to show you first like how the total phosphorus in wastewater treatment plants raw sewage looks like on county scale in all over the US. So on this plot, you were seeing that at county scale, what's the range of the phosphorus flow in tons per year from the wastewater sectors. And on the right hand side figure, you are seeing that how much phosphorus demand we have in tons per year for fertilizer. So this P fertilizer demand is solely coming from the mined P. So our target is, again, I'm saying our target is to meet the 25% of the mined P demand through wastewater phosphorus. So that's why we developed this metric to see how this offset can vary all over the US in a spatial scale. So these are the two results we are seeing, like on individual counties, how the PU's ratio varies from 0 to 1 and more than 1 scale. So here, if we say like if it is more than 1, that means that county is saturated, or that county actually has more raw sewage phosphorus to meet the local agricultural fertilizer demand at that location. But if that ratio is less than 1 or less than zero point 0.5, that is meaning that county has low raw sewage phosphorus compared to the mined P demand existing in that location to 50% or less than 100%.
And
So
Minhaz, can I stop you here for a second? So your assumption here then is that the phosphorus from the wastewater treatment plant is a perfect substitute for fertilizer, commercial fertilizer, correct? It's an ideal
yes.
case. Yeah, okay. So the actual numbers will be probably quite a bit lower than this because, they're actually, in truth, they're not completely interchangeable, correct?
Yes.
Great, thank you.
From this analysis, actually, we identified some of the hotspots. Like we found that the major cities had the largest treatment plants, and because they actually have the largest treatment plants, they are actually treating a lot of wastewater in those locations. And this is actually quite visible that the in that respect, these cities actually has a lot of raw sewage phosphorus incoming into the treatment plants compared to the local agricultural demand, because the major cities are often located far away from the agricultural lands in most places. So we can actually see the mine P demand also exists in the Midwest. That is a lot, like 3,000 to 9,000 tons P per year. And uh, in the urban wastewater, in the urban counties, we often see the PU's ratio is actually more than 1. That actually means that urban counties has less agricultural P fertilizer demand compared to the raw sewage phosphorus that is incoming to treatment plants. But in the rural Midwest and those places, we often see their PU's ratio values at around 0.25 or less than 0.25. That means they have less than 25% of the mined P demand in their raw sewage phosphorus. So in this spatial analysis, we found is an spatial mismatch or disparity between the urban and rural counties that actually can be resolved through an integrated phosphorus management system, so that we can develop a supply system between the counties to meet the agriculture for phosphorus fertilizer demand based on their needs. And coming to the 200 treatment plants, we worked on their sewage sludge disposal, like what are the categories they use. So there are most agriculture, land application, landfill, incineration, land reclamation. So what actually we found, like there is almost 50% of the sewage sludge they are actually land applying to the agricultural lands. So this 50% is actually the quantified in the with respect to the total sewage sludge phosphorus exist in those locations. So what we found is around 47%, and there are also like landfill 27% and incineration 14% represents. So these are actually showing us that a very good opportunity to mine phosphorus from this landfill and incinerated pathways, so that we can recover the most out of it to meet the local agricultural phosphorus demand in the US. So the key takeaways from this paper is we found the largest 200 plants accounts for more than 50% total phosphorus, and that is zero point 0.3 million metric ton phosphorus each year. And roughly 50% of the phosphorus is actually being land applied in the agricultural lands that is existing in the largest 200 plants. And in the county level phosphorus utilization analysis, we saw that there is a disparities between the urban and rural counties that can be actually well integrated through a phosphorus management system to meet the rural agricultural demand with the saturated phosphorus existing in the urban counties wastewater treatment plants. So, in the targeted P recovery, the largest treatment plants actually can be more viable to actually build this phosphorus circular economy in the US in future. So, given that, I am closing my talk, and any questions is welcome.
Great, thanks so much, Minhaz. That's great. Just one question for you. So you mentioned this spatial mismatch between the urban production of biosolids and their end use in agricultural fields in rural areas, especially. Um, you know, when we talk about manure management, it's often said that we can only transport manure economically for, I don't remember what the figure is, if it's 10 miles or 10 kilometers or something like that. But you mentioned in your paper that we're currently shipping biosolids from, for example, from California to Arizona, so hundreds of miles. Why is it that we can only ship the one for, 10 miles or so, but we can ship the other for so many more miles?
Yes, that's a great question. So, yes, there is a difference between manure and sewage sludge, phosphorus, sewage sludge product. We can say that depends on the moisture content at the first. So, in most of the treatment plants, there is a dry watering system that actually reduces the volume of the sewage sludge, and that is often economical compared to manure. Like manure is like a little bit like slurry, and so from the moisture content perspective, there's a difference between the manure and sewage sludge. Also, there are some regulatory obligations that can play in the role, like if there is phosphorus saturated zone exists and they have some banning on the pathogens or other contaminants like PFAS. So that in that way, that actually poses it's more economical or more environment friendly to supply the Swiss floods to some other counties where they have the phosphorus, they have the permit for land applying this Swiss floods. So the moisture content and the regulatory aspect actually can play a very big role here.
Great, that's great. Thanks so much for that answer, and also thanks again for providing this presentation. It's a really nice paper, and I wish you luck. Hope we get you some more coverage for it here.
Thank you so much.